Welcome to my channel. Um, what I'm going to do in this video is to show you the proposed solutions to question 3 of our revision exercise, the antenna models. So basically the questions uh, is about um, the calculation of the array factor for the array as shown on the right hand side. Yeah, we have four antenna placed along the z-axis, and the spacing between the antennas is lambda over 2. And we need to determine the phase shift, and we expect the antenna to be an end-fire antenna, where the maximum is towards the uh, the front end of the z-axis. And finally, we are going to work out all the nulls. Okay, so basically the question is very simple, and we are going to work it out. So to begin with, uh, let me see. Yeah, to begin with, uh, uh, an antenna array. Yeah, and this is the z-axis, x-axis, and y-axis, and the spacing between the antenna array is b. And suppose we are observing in somewhere here, yeah, like this, in far field, and all this, all this beam here, supposed to be parallel, yeah, in far field, and the elevation angle is theta, 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 theta. So progressive phase shift, the phase difference between two neighboring elements here is d cosine theta. So clearly, the phase difference should be the physical distance multiplied by the wave number. So if I interpret clearly, the phase difference between any two labeling pairs of antennas is going to be k d cos theta. And remember, we express the maximum radiation is in the z direction. So eventually, you may have radiation so it will be like this. Now I will just show you more clearly. So this is the radiation we expect. Okay? Uh, okay, I suppose this is clear enough, right? I will more clearly. Yeah, this is the kind of radiation we expect. Okay, so in this case, if we just use the phrase without adding any progressive ratio, then we will have both side radiation in these two sides. But by adding some phase difference, will make a difference. So suppose that add the phase difference is beta, which is also called progressive phase, then the total phase difference will become like this. This one is due to the physical distance t, and this one is due to the artificially added uh, progressive phase. Okay, so now the part A of the question asks for the general expression of the array factor. Well, as you can know that the array factor is going to be the summation of this element, and this element, and that element. When we add them together, then if we do it carefully, the first one was no one to compare with, so it will be zero. So this is what I get. So this is another equation. I see this is equation one. Another equation that you can come up with is to multiply the whole equation, equation one, by the exponential j theta. What you are going to get is get another. So this is what you are going to. Okay. So basically, there are two equations. One is the is derived from the original arrangement. The other is is derived from uh, uh, equation one by multiplying equation one with this. So if we find the difference between equation one and equation two, we will end up with one. Then here, this is very clear here. This and this can cancel out with each other. So we end up with only these two terms. Okay, so uh, exponential of zero is one. And this one is okay. So now it's quite clear. The AF can be worked out. Now the expression here can be further simplified. We can multiply the top and bottom something. Say in this case, the top one can be multiplied with minus j2, right? And then plus them again, and then multiply the opposite. So essentially, the top expression has no change in value, and the bottom expression can be this half minus, and then okay. So the bottom expression is similar. They have no change in value. So now we are going to simplify this. Yeah, we are going to simplify this one and this one. So I know, and this one is going to be this one and this one merged together. So it's very clear. Um, and do not forget that these two combined again will be J, B. So what we will end up with here is 9 to and then 5 to 10. Considering the fact that X number, it will not contribute to any magnitude. And this term is has nothing to do with the shape of the beam. Shape of the beam will be dictated by the middle expression here only. So in this case, we can say the normalized array vector equals we can say the normalized array vector being equals to. So the proof is done. This is the answer to part A of the question. Okay. Now the second part of the question is to find out the condition where you will end up with n via. N via means uh, n via means the beam is pointing to the forward direction. So we want the beam to happen. We want the maximum of E to be at either equal to 0 degree. So this is what is dictated by the questions. And we also know that the maximum occurs at phi equal to 0. And we know that it's in London. So going back here, this guy, the total phase shift is going to be equal to cosine theta plus the speed. You also know that K is 2 pi over lambda. D, according to the question, is lambda divided by 2. Now, the next thing that we are going to do is to substitute this division and we need to find out value of beta. So by substituting beta equals to 0 and we get, and this is become pi cosine, and then we need 0 here. So obviously, under this condition, beta is equal to, okay, I hope this is clear. Now, we are going to substitute this back to the original equation. And we know y is going to be pi cosine theta minus pi. So this is exactly what is asked for, the part B of the question. Okay, so we have proven that. So this is part B. Okay, part C. Part C is about finding the nulls. And this is a very common exercise when we are evaluating and tell our rate. The nulls are very important. Two neighboring nulls and end up with the P. Okay, now we are going to work out part C and the nulls, of course, I 2 pi is equal to 0. Under this condition, we know that in order for this expression to be simple, we need 2 pi equals to pi plus or minus pi plus minus 2 pi plus or minus b pi and then go on forever. And this guy here is equals to um, 2 times pi cosine theta minus 1. So according to the previous part of the question, yeah, that's what we get from the expression of pi. And we want this one to be equals to plus or minus pi plus or minus 2 pi plus or minus 3 pi, etc. So we need to examine each of these individually in order to take out all the numbers. So let's try this first. Pi, case 1, where 2 pi equals to plus pi. So in this case, cos theta minus 1 is equal to pi. So in this case, cosine theta is equal to half. Cosine theta minus 1 is equal to half. So obviously, this means cosine theta is equal to 1.5. So there is no solution because sine theta, the maximum of sine theta is 1. No solution. In case 2, 2 phi equal to minus pi because we need to examine both plus pi and minus pi. Otherwise, if you don't do that, the final answer is not going to be complete. So let's do this minus pi. So apparently here we have solution in this case. So in this case, it's quite obvious. Cosine theta has to be equal to 1 over 2. So this means theta is equal to pi over 6. And another angle is, in the second quadrant, there is another solution for sine theta, which is pi minus pi root 6. So what we end up with here is 60 so 112 degree, right? This one is 60 degree, right? And now we are going to examine this one. We are going to examine 4 pi first. So when you have this equation, 2 pi, this one will become 1 cosine theta. So in this case, so obviously there is no solution. Yeah? Minus 1 move to the right side and then it will become 2. There is no solution. So we need to find out case 4. In this case, case 4 will be 4 pi. So under this condition, minus 2 pi, and we have minus 1. So obviously, we have solution. In this case, this means cosine theta is equal to 0. And what condition? Under the condition, yeah, in this case, this is very obvious. Theta is equal to 90 degrees or 270 degrees. So all the nulls can be found out under this situation, depending on the range of theta that we are given. And in this case, I can bravely say that theta is equal to 60 degree and then 90 degree and then 120 degree and then 270 degree. Okay, so this is what we get. Depending on the range, if the question allows you to extend the value of theta from 0 to 360 degree, then this one will be included. Otherwise, this one should be discarded because normally, yeah, uh, theta should be from 0 to pi. Okay, so if you have any question, you can leave your question to the comment section of this video, and I will address each of the question individually. Yeah, you don't have to be a student of BGU in order to be eligible to ask question. Okay, thank you.